So this next part of chapter 13 is solving for drops per minute. And these can be written down in several different ways as far as solving for. But on these, we're going to round to the nearest tenth for these problems. So I have a 1,000 milliliter bag of normal saline to infused over 10 hours. And our tubing drop factor is 15 drops per milliliter. So again, I'm going to take this information. So I have 1,000 milliliters to infuse over 10 hours. And my tubing drop factor is 15 drops per milliliter. And I want to solve for drops per minute. So with our dimensional analysis, if we're solving for drops per minute, I want to start my problem out with drops. So here's sentences. Sentence 1, sentence 2. So I find our information that has drops in it. So we'll see here we have 15 drops per milliliter. And rules of dimensional analysis tell us if milliliters is here, milliliters has to come here. So in our other sentence, we have 1,000 milliliters over 10 hours. And I always go back to see, is that where we need to stop? No. So again, rules of dimensional analysis say if this is hours, this has to be hours, and we're going to minutes. So go back to your known conversions of 1 hour is equivalent to 60 minutes. Ultimately, milliliters are going to cancel out, our hours are going to cancel out, and we're going to be left with drops per minute. So now we take 15 times 1,000 times 1, gives us 15,000 over 60 times 10, gives us 600. So 15,000 divided by 600 gives us 25 drops per minute. We didn't have to do any rounding there because we're left with that whole number. Okay, so next I'm going to do, I'm going to go ahead and do a few of these because this is, you will see these a lot on your, not only your homework, but also your exam for the week, and then also your final exam. So in this case, this one is 750 milliliters of normal saline is to be infused over 8 hours, and our drop factor is 15 drops per milliliter. So here again, 750 milliliters over 8 hours, and our drop factor is 15 drops per milliliter, and again we're solving for drops per minute. So dimensional analysis, solving for drops per minute, I'm going to start out with drops, and here's the information that has drops. 15 drops, 1 ml. This is mLs, what has to come here? mLs, our other information is 750 mLs over 8 hours. And again, I always look back, is that where we need to stop? No. So if this is hours, this has to be hours, and I want to go to minutes. And since we're not given this information, we have to go back to our known conversions. So 1 hour is equivalent to 60 minutes, leaving us with being able to cancel out our milliliters, cancel out our hours, being left with drops per minute. So I'm going to do 15 times 750 gives us 11,250 over 60 times 8 is 480. So then 11,250 divided by 480 gives us 23.4375, and again it tells us to round to the 10th, so that's one place past the decimal. So with this one I'm going to have 23.4 drops per minute. Okay, so the next one here is 50 milliliters of normal saline to be infused over 60 minutes, and our drop factor is 160 drops per milliliter. So I'm going to have 50 milliliters over 60 minutes, and our tubing drop factor is 160 drops per milliliter, and again solving for drops per minute. So drops per minute, solve for drops on top, go over here, so 160 drops over 1 ml, which is this sentence, and then this one is going to plug in our other one, so mLs have to go here, so we have 50 milliliters over 60 minutes, and again I always go back at this point, is that what we're solving for? Yes, so we leave that as is, and now our milliliters are just going to cancel out, so we have 160 times 50 gives us 8,000 over 60, and that gives us 133.3 repeating, so rounding that to the nearest tenth is 133.3 drops per minute. Okay, and the next two are very similar to what we've just done, and actually let's skip back here to this back one, and it just gives us a little bit different information. So in this one we have an IV fluid is infusing at 125 milliliters per hour. Our drop factor is 10 drops per milliliter, so 125 milliliters per hour, and we have 10 drops per milliliter, and again we're solving for drops per minute. So since I'm solving for drops per minute, I want to start out with drops. So here's our 10 drops over 1 milliliter, and since this is milliliters must come here. So we have 125 milliliters over 1 hour, and I always go back, is that what we're solving for? No. So I need to go from hours to minutes to get down here. So we have 1 hour is equivalent to 60 minutes, ultimately canceling out our milliliters and hours. So I'm going to do 10 times 125 gives us 1250 over 60, because 60 times 1 times 1, and that gives us 20.83 repeating, so rounding that to the nearest tenth is going to be 20.8 drops per minute.